In this entry of the xaq-ai diaries, we are seeing how the LLMs I was using to build the code are cheating at the system that I'm trying to build. Even though I was trying to control the principles and the design constraints as best as possible, the cheats will leak in by bringing some part of the world into that Markov blanket. I may not have been using the term at the time, but that's the problem. It'll get an oracle that comes in from the sky and it starts using it, and I miss the fact that it's using that, or it was a scaffold early on, meaning that we're using it to prop up the system as it was getting built, and it gets left in there even though I thought it was getting removed. So that's a whole thing. Check it out. All right, is this thing actually alive? I really hope so, because these agentic coding tools really love to sneak in cheats into this program. So let me just show you what we've got as of today, April 14th, at around 3 o'clock. So here's my list of, basically this is my experimental setup. Right now I am only running 2 EPMs. Keep things simple. I got my saliency EPM and the proprioceptive one. All of the encoders, everything is geometric. There's not a neural network in sight. Everything is just using graphs, geometric math, right? There's no weights, nothing like that, unless I want to save the Hebbian weights, the Hebbian associations, in the main knowledge graph. But I don't even have to do that, it seems. So I'm not even using the microphone, none of that stuff. Just the proprioceptive, which does take in the proprioceptive EPM does take in information as if the paddle is an organism. That part was really important, and I think that's fair, right? It has an idea of where it is in space. It knows its acceleration, and it just has some awareness of its paddle, just like you are aware of your arm, right? So that's the proprioceptive EPM. And then that's paired with the saliency one, so it can see the thing move. It can see the paddle move, and it can see the ball move. Really, those are the only things that matter for Pong, right? So it's in active inference mode. I'm going to disable the motor babbling, so it's only doing inference. This part I haven't even finished yet to actually get rid of raw ball telemetry. Actually, I'm going to leave it on for now just so we can watch it. And because I didn't actually finish putting that in, I ran out of tokens, so really I'm just kind of checking this out. But anyways, I can up the Hebbian learning rate quite a bit now because it actually means something. This is where I could actually save a checkpoint for the Hebbian graph, but so far I haven't really needed to do it. But if I put in a new name like test 4, then it will actually save something to the disk, and it's valid. So what I'm going to do is I'm going to do a 300-second run. It's going to observe basically just on autopilot, just in demo mode for 30 seconds. That kind of gives the Hebbian graph a chance to wait up. I'm not doing any kind of random motor babbling. I'm turning that off because that kind of like makes the ball jitter around just so it's not still. We don't really need that if we've got a real time loop error thing happening, right? So motor babbling was sort of a idea that Gemini had, but really if we follow the real principles in playful machines, that should not be necessary. Just it should find even the smallest thing to like do something off of, and right now it actually seems to be doing something off of the ball. So let's launch it. I'll describe what we've got here. So here's my observation deck. Where's the game? There it is. It appeared over here for some reason. Okay, so it's in observation mode right now. I'll leave that up on the screen. Okay, it's so right now if we look over here, it's building new nodes. Proprioceptive node doesn't really need a whole lot of information, so it kind of tabled off. Building more nodes. Usually this stops at around 60. And now it's alive. And it's tracking the ball. Now, this is where I'm very cautiously optimistic, is like, why is it so good? Right? Because it sucked so bad before. And last time it was good. See, this is where I'm like wondering, what is it actually responding off of? Is it responding off of the resonance of the graph? Because one thing that it has been very consistent, even though this graph needs some TLC to get it to quit flipping out, but it consistently creates this sort of Y-shaped latent space. And it's definitely not perfect. You saw it miss. That decreased the Hebbian associations for that short period of time, that history that was baked into the association matrix over here. You can see that the saliency encoder is actually doing some kind of tracking of the ball. Sort of. Kind of loses its mind once in a while, but it's kind of tracking it. At least we're getting good stable nodes. Like I said, it kind of like tops out around 60 nodes from the saliency graph. And right now it's missing. It's around 35%, but some runs it gets up to 60. It's kind of luck of the draw. But why is it so smooth? Right? And then it can, sometimes it'll catch up. But then later on, as it gets farther and farther along, that paddle seems to slow down. But the way the paddle's moving is less deterministic and more like it's trying to figure out what's actually happening. So it tries to like find it. It doesn't, that's weird. Sometimes the ball gets stuck on the side. I don't really know why that happens. I think that has to do with, I did add like a random element to it. So you can see the ball's actually, so this is interesting. The ball actually got stuck and now it's at a totally different angle. And the system is learning to follow it. If it was just, well, I don't know, right? So one thing that we really need here is we need to be able to turn off all of the telemetry. So right now we've got this way of, we bring in the telemetry of the paddle position. That's the green graph. The green graph we need because that's actually the part of the proprioception, right? So the ball needs to know that it exists relative to the body, right? For now, like it does know its position, right? That goes into the EPM. It knows its acceleration and stuff like that. And the only input that the motor controller has is basically the same as pressing the key on the keyboard. If I press the key down, it accelerates to the left. If I push the right key down, it accelerates to the right. So it actually has the same kind of input off and on to move the paddle. So right now it's like tap, 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 tap when it moves slow like that, because it has the same kind of ballistic. It's not holding it down. It's like a series of taps. And it's probably noisy. That could be why it's kind of moving slow like that. But it's doing something. It's definitely like following the ball, and the fact that we're above 40% means something. And then it sort of tops out and gets worse. I think that's probably because we got a lot of nodes here, and we still have a problem of it making new nodes that are just sort of noisy. And I have to go back into the EPMs themselves and figure out why they're getting noisy and why they make nodes that are not, maybe I just need to turn the sensitivity down. They should just be baking. Maybe after they get baked, maybe there's a chance that they get baked fairly quickly, but then they also degrade very quickly. So I'm not really sure. The number of nodes is falling now, so that's good. But the fact that it has a tendency to creep up, that's not great. And that's probably causing some of this inaccuracy. But one thing that we are seeing happening here is like this predictive graph. So keep in mind, saliency is also seeing the paddle. And the fact that we've got this nice amount of like resonance happening, that seems pretty good. So anyways, even if I disable the reflex, that was already disabled. That was the basically the random motion. Random motion's been taken out of this. So this doesn't actually do anything. But anyways, that's the end of 300 ticks. So if we look here, the learning curve, basically what happened, it starts off really, really strong. And then it drops. Like, is that random? I don't know. Why is it super good in the beginning? We were up at 50%, and then it kind of drops, right? And the very last one has 0 because it actually cut off at second 180 or at second 300. So it didn't actually collect anything on the last one. I don't know. I got to dig into it some more and figure out what's really happening here. I need to make sure that the ball X position is not actually leaking into this, because if it is, then it's back to the drawing board again. So basically what was happening, I got very hopeful that things were working well, but the ball X position was actually leaking into the brain. It was learning against that oracle. So the fact that it knew the ball's X position, the horizontal position of the ball, it was learning to move against that value, but that is not real. It was not using the vision EPMs. It was fake. Had to throw the whole thing away.